సబ్స్క్రైబ్ చేయండి ఫర్ మోర్ అప్డేట్స్ బెల్ ఐకాన్ క్లిక్ చేయండి ప్లీజ్ లైక్ అండ్ షేర్ చేసి కామెంట్ చేయండి
Gauss's law and its proof. First of all, what is the Gauss's law? The statement of the Gauss's law: the total electric flux through a closed surface, for example, this is the closed surface. The closed surface is equal to 1 upon epsilon naught times the net charge enclosed by the surface. So the electric flux is denoted by phi suffix e. The total electric flux through a closed surface is equal to 1 upon epsilon naught times to the net charge. So generally the Gauss's law is equals to phi suffix e is equals to q upon epsilon naught. That means phi upon suffix e is equals to the net charge into 1 upon epsilon naught times. So 1 upon epsilon naught times to the net charge enclosed by the surface. This is the statement of the Gauss's law. The statement of the Gauss's law is the total electric flux through a closed surface is equal to the 1 upon epsilon naught times to the net charge enclosed by the surface. Okay, here epsilon naught is the permittivity of the free space, q is the net charge. Okay, here there are two proofs of Gauss's law. One proof is the in spherical shape and another is the any Gaussian shape. Proof 1, first is the proof 1. Let us consider an isolated point charge q plus q. Let us consider an imaginary spherical surface. This is the spherical surface whose radius is r. This is the radius is r. Okay, this is known as Gaussian surface. Consider a small element of the surface. This is the small element of the surface. This is the ds. An electric field, the direction of the electric field is the same. Then the angle between them, the elementary surface and electric field, the angle between these two is 0. Now the electric flux. First of all, electric flux phi suffix e is equals to closed surface integral e dot ds cos theta. Phi suffix e electric flux is equals to e dot cos theta closed surface integral ds. Okay, next closed surface integral electric flux is equals to e dot, here cos, there is the 0 angle between e and ds is equals to 0 degrees. Closed surface integral ds is equals to capital S. So the electric flux is equals to e dot cos 0 is equals to 1 and into S. S is the total surface. Total surface is nothing but area. Electric flux is equals to E into A or E into S. Total surface is nothing but area. This is the our electric flux. Okay, so then the electric flux is equals to E closed surface integral ds, that is equals to E into A. A is the area of the sphere. Area of the sphere is equals to E into 4 pi r square. This is the area of the sphere. Area of the sphere. This is equals to this is equals to electric flux is equals to then E dot 4 pi r square. 4 pi r square. Okay, then but E electric field formula is equals to 1 upon 4 pi epsilon naught q upon r square. We know that this is the electric field. This electric field is substituted in this equation. So electric flux is equals to E means 1 upon 4 pi epsilon naught q upon r square, then 4 pi, here radius is the r square, where capital R is equals to here small r. Okay, then electric flux phi suffix E is equals to 4 pi is the cancel, r square is the cancel, then remaining q upon epsilon naught. This is the total electric flux is equals to 1 upon epsilon naught times 2 net charge. Hence the Gauss law is proved. This is the first proof. Our second proof is the any Gaussian surface. For example, this is the any Gaussian surface. At point plus q charge, the electric field, this is the electric field. This is the some elementary ds. This ds, this is the ds angle. This is the point P. Okay, same, we construct the some solid angle. This is the solid angle. This solid angle is denoted as the d omega. This is the small r. The distance is the smaller any point P. Okay. Let a charge plus q is placed at O within a closed surface. This is the irregular shape. Consider ds is an element of area around the point P. This is the point P on the surface at a distance small r. Then the normal to the surface which makes an angle is the theta. This is the theta with electric field. The electric flux phi suffix E outwards through the area of surface ds is given by general formula electric flux closed surface integral E dot ds. From scalar product, the electric flux is equals to closed surface integral. This is the scalar product, is can be written as E dot ds cos theta. This is the scalar product. This is a scalar product. But electric field is equals to 1 upon 4 pi epsilon naught q upon r square. Q upon r square. This equation is substituted in this equation. Okay, so that equation can be written as closed pi suffix e is equals to closed surface integral at the e 1 upon 4 pi epsilon naught q upon r square into ds cos theta. ds cos theta. This equation can be written as phi suffix e is equals to where q upon 4 pi epsilon naught, q is the constant, 1 upon 4 pi epsilon is the constant, then closed surface integral ds cos theta upon r square. Here r is not constant because r is the constant distance. R is not constant distance. R is not constant. So it's a integral value. So pi suffix e is equals to q upon 4 pi epsilon naught closed surface integral ds cos theta r square. This is the is equal to solid angle. This is the solid angle. So this is the solid angle. This is the solid angle. Solid angle. This is the solid angle. What is the solid angle? What is the solid angle? Elementary solid angle. So then this equation can be written as phi suffix e is equals to q upon 4 pi epsilon naught closed surface integral d omega is equals to total omega. Total omega. Okay, total omega, we know that the value of omega, the value of total solid angle omega is equals to 4 pi, we know that. So then pi suffix e is equals to q upon 4 pi epsilon naught omega is equals to 4 pi. The 4 pi is the cancel. Phi suffix e is equals to q upon epsilon naught. Q upon epsilon naught. So the total electric flux is equals to 1 upon epsilon naught times to net charge. So this is also Gauss's law.